Yeah, so some of us, or the organizing committee, tried to figure out the best way to do this meeting summary. It's a pretty difficult task to do because of the time commitment and because of the wide breadth of and scope of all these talks. But we decided ultimately to try to tackle this together. Some of us on the organizing committee. So I'll be presenting some of the first slides. Abigail is going to be presenting some of the slides as well, and then Leo is also going to be presenting some of the slides. And all of this has kind of been a synthesis and contribution from all the members in the SOC. All right, so I'd like to start off with some initial impressions or takeaways from the meeting. But before I do so, I'd like to kind of again share these high five themes of the meeting that highlight the key technical themes of ground-based mid-IR observations in the era of JWST. One interesting thing that I actually learned during the meeting, there's this high contrast imager on the VLTI called high five, which is, so that's not to be confused with this, but this is a very interesting instrument as well. So our high five themes are high spatial resolution, high spectral resolution, high contrast imaging, high background, and high cadence and time resolution.
Ryan, sorry to interrupt, but you're not in presenter mode yet.
Oh, really? What is going on then? How about now?
Yeah, that works.
Okay, is it still going? Okay. All right. So yeah, we heard some really great talks that covered all of these categories. And so having listened to all of these intriguing talks and discussions, I would say that my impression, one of my initial impressions was the following. The JWST will be revolutionary, of course, and a major game changer, not just in infrared astronomy, but the field of astronomy in general. However, ground-based mid-IR facilities will continue to push the science and the limits covered by these high five themes. And I think this is especially true for observations that exploit high spatial resolution capabilities. And I believe this also reflects the majority of our contributed abstracts in IR2022 that focus on this particular theme. Okay, so in the following slides, what I'll do is I'll go through some of the impressions and thoughts that I had from days 1 and 3 in our meeting. And then I'll pass the floor to Leo, who will step in and cover his impressions on day 4, which covers the AGN science. And then Abby will share her summary on her discussion on diversity and inclusion, as well as science themes on day 5. And so yeah, that'll be the overall format of this kind of summary, closing summary talk. And so again, I also want to thank the SOC chairs who have provided their feedback on some of these points in this summary talk. Okay, so let's get started. That is the end slide. Hang on, that was weird. All right, okay, this is the right slide that I wanted to show. So on day 1, we covered this overall theme of resolving star and planet formation, both spectroscopically and spatially. In fact, I think the main takeaway from day 1 seemed to be that both high spatial resolution and spectral resolution are critical for pushing our understanding of star and planet formation, and perhaps even second generation planet formation physics, chemistry, and dynamics. So in her talk, Sierra Grant also emphasized that high sensitivity is important, which we can get from space. But this is also implicitly emphasized by the talks in the second session of this day, where the large distances to the objects and the small current sample sizes emphasize this point. And so this is something that can explore with ELTs in the future. So it also seemed to me that there was a consensus that there's a need for large coordinated observing programs, not just for this science mode, but not for just this science theme, but others. So I think this is something that the community should absolutely organize and pursue. So we should, yeah, totally go for it. There is also a resounding consensus that the mid-IR community should continue to push for a high spectral resolution IR space mission in order to achieve the higher sensitivities that we need. And so I was informed that by high spectral resolution for a space based spectrograph, it would be great if it's above an R of 50,000, so you don't lose the sensitivity to the 10 AU regions of these systems. Okay, hopefully this doesn't go all the way. All right. Okay, so one of the other things that I was absolutely impressed by was hearing the advancements in mid-IR interferometry all the way from 1974. And so this was covered in Bruno Lopez's talk. So I think the future of high angular resolution observations in the mid-IR, at least in the near future, will be in interferometry. And we kind of touched on this in the previous discussion. We're also presented with, I think, a really great opportunity to explore synergies between different interferometers, VLTI, and with JWST. And I think this presents new opportunities for us to engage the broader mid-infrared community in mid-IR interferometry and making this mode more accessible, since I think it'll be very important to achieve our high spatial resolution capabilities. All right, so on day 2, we heard about exoplanets and the promise of the mid-IR. It was really impressive to see the large discovery space for exoplanet characterization, both from the ground and space. It was also exciting to see how the limitations of high contrast imaging are continuously being pushed by new exciting and planned IR facilities, such as the LBTI, VLTI, and also MIRAC-5 on the MMT. And of course, it was really nice to see these exciting results and planned observations from exoplanet surveys such as HOST and lessons. And so I also wanted to note that I was really quite surprised at how deep some of this AO-assisted sensitivity can get with the LBT at LNM. And so I think that could be valuable for many science cases beyond exoplanets. And so, okay, so yeah, speaking of the promise of the mid-IR, we were reminded of the immense sensitivity gains for direct detection of exoplanets to be realized with the ELTs. So in Kevin Wagner's talk, he had noted that the LT will be able to achieve exo-Earth sensitivity around Alpha Centauri within hours. That would be a pretty amazing gain. However, this notably comes with the caveat that it's crucial to consider the impact of water vapor on this high contrast imaging capabilities with ELTs. We also saw some talks that showed promising ground and space-based synergies for exoplanet detection. For example, gravity and JWST. With the aperture masking interferometry mode, and this image here on the right is from Jan's Kammerer's talk. And also in the discussions, it seemed there's an emphasis on utilizing new mid-IR detector technologies. So we also had a nice reminder that facilities such as LBTI and Palomar continue to be valuable test beds for this, for new instrumentation, and I'm sure also for fostering the next generation of instrumentation experts as well. Lastly, I wanted to bring up this point here, or the last thing about day 2 that I wanted to bring up is this point here about considering the role of mid-IR polarimetry for ELTs and future space missions. So that seemed to be kind of a recurring theme. All right, so on day 3, we're reminded the importance of looking up in Thomas Muller's talk, as well as facing these immense technical challenges of ground-based mid-infrared observations. So such technical challenges are being faced in the development of the Mimizuku instrument on the future Tokyo Atacama Observatory. For example, the high background emission from the atmosphere can be mitigated with the cold chopper that they're developing. Atmosphere correction and high photometric precision can be achieved using the field stacker. And also flat corrections can be conducted using the onboard calibration unit. So this was all reviewed in Kamizuka-san's talk on day 3. Also, we were introduced to the drift scanning technique that could increase the signal to noise and Strehl ratio in the mid-IR, and that could be a promising mode to be implemented in Mimizuku. We also had a nice series of talks on how ground-based facilities enable key mid-IR observing modes for solar system science and also near-Earth object monitoring some of which may alert us if there's an asteroid coming our way. So these would be particularly nice to have. There was also an interesting consensus between these talks that emphasized the flexibility and sky coverage of ground-based mid-IR and how this remains critical even in the era of JWST. All right, and so in day 3, we also witnessed an explosion of new transient science in the mid-infrared. So like in Thomas Kaminski's talk, we saw how the mid-IR can probe hidden physics of obscured stellar mergers and how they can reveal interesting properties of the mass loss and stellar evolution in these stars for binary stars. We saw a very nice ingenious convergence of technologies by Daisuke Taniguchi using the Himawari 8 weather satellite. And so we have this uninterrupted 5-year light curve of Betelgeuse with this weather satellite, which is really quite amazing. And it just happens to have captured its great dimming event. So it's just very amazing and interesting results. It skipped all the way to the end again. I don't know why I did that. Sorry. And also, we heard about tracing dusty origins of nuclear transients and also neutrino sources in Robert Stein's and Stefan Mattia's talks. So another intriguing use of mid-IR observations to probe the hidden physics of transients. And lastly, Monty Calziwal demonstrated that the mid-infrared is a very unique probe of the synthesis of the heaviest elements. So in this image that she shared, this is showing a Spitzer observation, and I think 4 microns or 4.5 microns, that's capturing this mid-infrared emission from the heavy elements in the first electromagnetic counterpart of a gravitation wave that we've ever detected. So I think this really sets the stage for the mid-IR in transient science. So the mid-infrared will continue to play a key role in this era of new transient discovery, especially with LSST and these other, or Rubin, and these other ground-based near-infrared surveys that are being developed. And especially, I think, in the era of multi-messenger astronomy. Okay, so that's my summary of the first 3 days. I'm going to pass the floor on to Leo. And I guess I could continue sharing the same slides. And so I'll skip ahead.
Yes, if you can just continue to share the slides, that would be good. Okay, so day 4 was the AGN day and the diversity day. And it was kicked off by a summary talk, a review talk by Cristina Ramos Almeida, showing us the really rich diversity of observations and also simulations that exist for AGNs. It was a very nice introduction to everything that we heard afterwards. And then we really went into very much detail of one particular source, namely NGC 1068. That is, of course, a very famous source for everyone working on AGNs, the prototypical Seyfert galaxy. And we heard an interesting contradiction of 2 very recent results. So last year, the Gravity collaboration published their K-band image that is seen here in the lower left. That was interpreted by various people, including Pierre Vermeaux, who gave a talk about this, as seeing the innermost dust string, the innermost hot dust in the K-band. And then just very recently, namely 2 days ago, the MATISSE collaboration led by Violeta Gámez-Rosas, who gave the talk about the MATISSE results, published the first MATISSE observations of an AGN at all, of 1068. And there you can see this really amazing picture that is actually also on the ESA website now and published in various newspapers around the world, big press release. And that is interpreted as seeing really the outflow, so to say, the innermost, the inner funnel, the inner hot part of the AGN. And the black hole is located just below what you can see there is the inner dashed line, not actually where the ESA press release puts it, but where it is in the Nature paper as discussed in the Slack space too. And that would really very much argue in favor of a classical unified torus, like in this picture to the right that we have almost thought we could throw away if it's true. But then, next slide, please. Jacob Isbell showed us the results for the other bright AGN, so 10 Jansky or so AGN that can be studied in a lot of detail with the VLTI MATISSE. where the result or the conclusion that Jacob drew from his paper that has just been submitted recently is it is not a classical torus. So I think the jury is still a bit open about whether or not there is such a classical unified torus or not. And perhaps we can already say that it's certainly not unified in the sense that it's going to be the same thing in all galaxies. I think that can be said. Next slide, please. But then our SOC chair and hopefully not too tired manager of everything here, Ryan, made the comment in the Slack space. So is AGN torus the same kind of misnomer as planetary nebula, which received 15 replies, and I think even more until now, with lots of discussions of yes or no, or yes or no. So there's certainly not an agreement yet in the AGN community whether we should get rid of that word or not. Next slide, please. But then that day also saw a number of really, a number of other talks. Cannot highlight all of them, especially because there was also really a large number of posters. I think the largest number of posters for all of the sessions that I can only really recommend to check out. They're all really nice. And also one pre-recorded talk that should be checked out by Ms. Xi on PAHs actually. But then I think the picture that really blew us all away most, as usual, as also already at IR2020, was one by Enrique Lopez Rodriguez, showing really amazing polarimetry on a nearby liner, Seaford, not quite known, I think, NGC 1097. Which you can see here to the left. So this is an overlay of various polarimetry measurements in various wavelengths from I think 80 micron up to a couple of centimeters. And you can see here how the polarimetry is really tracing the inflow to that galaxy from galaxy scales all the way down. And Enrique made the nice point that magnetic fields are at place at the very, very smallest scales, where the fantastic Event Horizon Telescope image shows this black hole shadow, and then also at the larger scales. And the in-between scale is really the torus, if it exists or not. And so we really should have polarimetry capabilities also for the VLTI at 10 micron to trace better what is actually happening there. Next slide, please. Then there were a number of talks about what the future will give for mid-infrared. And I highlight here an image from Almudena Alonso Herrero, who had a poster, just to make sure that people also check out posters, a simulation, relative transfer simulation of a clumpy torus cut 3D wind model. And you can see here that actually just the random association or the random setup of the clouds gives this very complex image. I was pretty surprised, I have to say, personally, but with this image, I would have thought that a symmetric clumpy torus model wouldn't give so much patchiness. But then Jacob Isbell commented later on the Slack that this is also what they see for Jacob. So the ELTs will certainly be fantastic, of course, for studying this, but we have to wait still another couple of years. And then Chris Packham asked in the discussion session, next point, please, the question, so what can we expect before the ELTs? Is there still something going to come for AGNs, or do we have to wait until then? Well, of course not. I mean, James Webb, of course, is now up. And a number of us have proposals, or actually now programs on James Webb, and we're going to see fantastic results, the extended polar emission, more IFU with lines that we cannot get from the ground, and all the stable PSF and sensitivity advantages. But then there's a number of things also from the ground that we hope to make progress on in the next few years until the next infrared conference, perhaps 24 or 23, who knows. And again, Jacob pointed out that there was that we had a proposal actually that originated from IR2020 to observe again this famous NGC 1068 with LBTI imaging. Steve Ertl was also quite involved in this. That hasn't been observed yet due to, I think, technical setup issues, but hopefully that will come soon. And then also with interferometry, more AGNs should be observed in the next months and years, so there will be more results coming. But then another point that has already been made earlier by Ryan, so this new kid on the block, the new mid-infrared detector GeoSnap that will be featuring in the MIRAC 5 instrument, can make 8-meter telescopes quite a bit more sensitive, because we've seen that Visier is actually not background photon noise limited due to the ELFN. You can get away with it by very fast chopping, as we have seen from the NEAR results, but of course it would be even nicer to do this with a better detector. Yes, and there were a number of other talks that I couldn't cover here now in this very short time. I tried to highlight the things that that I put down here. But please check out the other talks. They're all recorded, and the posters are also all on the web to be seen. And then forward to Abby, I guess now. Day 5.
Thank you. So if you go to the next slide. So this is, I'll try to do my best to summarize today in the short breaks that we've had, so please bear with me. The two main things that stood out to me from today's sessions, across both of them, were the PAHS and dust and how stars are creating or contributing to both of these. So first, we had our starting talk from Els Peters, and we found that PAHs are important to consider when you're looking at your physical and chemical processes happening in various regions, from AGN to star forming regions. And I think the main takeaway point that I got from her talk was that we need JWST for some things, but we also can't count out ground-based infrared. And like, it's really a marriage of the two, which is going to give us the best views of the PAHs that we need. So for JWST, if we want to be able to look at the kind of substructure within PAH regions, then the medium resolution can probe this really well. However, the limited field of view of JWST and the fact that it will saturate for a lot of regions where PAHs are being generated means that we have to marry this with observations from the ground. And in particular, there can be a really nice synergy between looking at certain PAH emission lines and looking at their profiles and their behavior and using that to, those results from the JWST to tie to ground-based observations to help us to interpret this and get the best picture that we can of the PAHs that we're looking at. This kind of tied into also Cookie's talk, where she was talking about PAHs close to the galactic center, and also the really complex, beautiful dusty structures that we're seeing close to the galactic center. And I really liked the work and looking at how different temperature structures are happening across the different temperature gradients, happening across the structures in these regions, such as the bullet and these other kind of bubbles that have been blown out in these systems as well. If we could go to the next slide. We then went on to talking about dust creation, dust destruction, and stars as these kind of engines which are processing the dust that we have throughout the universe. First, we had the lovely talk from Mikako talking about supernovae, mostly about and how these are both creating and destroying dust, and how created dust cools over very short timescales. And it's not only that dust is being created during these events, but also the surrounding dust is being disrupted and being moved to wider radii and going through some evolution as well. And I also wanted to highlight the point that she made about dust composition and how this affects how dust is destroyed by supernovae, and how a lot of the models have very different kind of percentages of how much dust will be destroyed in certain events. And so I think it's really key for us to be doing these kind of studies of the dust composition of these regions to best understand how these regions are going to evolve in the future. In particular, she mentioned that JWST will be key for looking at its dust composition, and so I hope we can look forward to lots of interesting new findings about the composition of these dusty regions around supernovae in the future. Another kind of source that is creating dust within the universe are giant stars. We had a nice talk from René Aldemeyer about the fried egg and how multiple epochs of dust formation are leading to complex structures, which we can then probe in the infrared, and how collisions are exciting molecules and changing the chemistry within this dust as well. And we also had the nice talk from Randa Assad, who showed us that by using spectral studies, we can determine whether the massive stars and giant stars are coming from the same populations or multiple stellar populations. I thought this was interesting, relating this to Mikhail Mikhalski's talk, where he was talking about how potentially for JWST observations, there may be some confusion between when you're looking for stars to look for lensing events. So you kind of want stars behind the galactic center, but it's difficult to tell from a JWST image whether those stars are actually behind the galactic center or whether they're in the galactic field. And so perhaps spectral studies like this to accompany these sorts of searches for lensing stellar objects could be, could be complementary. If we go to next slide. And finally, we heard a lot about Wolf-Rayet stars and how these are key dust creators as well. We had two lovely talks from Izumi and Ryan, where Izumi was showing that we are seeing similar kind of spectral features across Wolf-Rayet stars, and Ryan was talking about how Wolf-Rayet stars in a binary system, and in particular these carbon-rich Wolf-Rayet stars, seem to be key dust producers in the universe. So if you think about post-AGB stars, they're creating a certain amount of dust in the universe, but like a single Wolf-Rayet system is also creating a huge amount of dust, like twice as much as that. And I think that means that these are kind of really key creators of like a large amount of interesting dust that we can be able to look at in the universe. And I also really enjoyed the number of tools that Ryan's team has been developing and working on, which can help not just for the study of this kind of Wolf-Rayet material, but also could be applied to a lot of different science cases, such as PSF subtraction, and also the use of SAM for looking at cool material, or faint material around brighter sources with GRAVITY as well. And I think that's it from me, if you want to go to the next part.
All right, so that kind of concludes all of the summaries and impressions of the days of IR 2022. And so we're going to start now with the kind of takeaway points of the meeting and kind of how we proceed in the future. So when we're putting these slides together, or we're kind of thinking of I looked at the past IR 2022 summary talk by Bernard Randall and Nancy Levison. And so they gave us these action items for all of us in this past meeting. So you can read them here. And so as I was reading through these things, I was considering if we hit these points in IR 2022. And I feel like we did do a pretty good job at this. We've, I think, tried to pursue or enable new observing proposals across different fields, trying to cross different specialties to try to see how we can improve other science. And I think that's what's really valuable for the mid-infrared community. I think we are also trying with this virtual meeting and with Slack and reaching out to build up the mid-infrared community, and also develop who we already are. Trying to use current instruments effectively. That's kind of the whole idea of this meeting, and then make the science case for future capabilities. So yeah, I feel pretty good about this this meeting and what we've been able to achieve in it. So what we decided to do, we created our own list of action items for all of us from IR 2022. And so I think what will be an important thing is to continue building up this mid-IR community from different perspectives. So from a scientific perspective, I think there was just a lot of consensus on how we can improve certain science themes, or what's the next step to take for pursuing certain observing programs. And that's, I think, to try to coordinate and to pursue large observing proposals. We also need to be really on top of exploiting synergies with GWST within these kind of high-five themes that we developed, or that we emphasized throughout this entire meeting. And also that it's very important to connect on instrument development and make sure that we're all aware of what's the new greatest technology. From a social perspective, I think we want to address how we organize future IR 2020X meetings, whether it's 2023 or 2024, or do we meet more frequently than that, yearly or every half a year? Or do we pursue different avenues of getting together and building up the communities, such as IR seminars, or perhaps instrument-focused workshops, which was one of the ideas that was proposed in the previous meeting. The last thing I'll mention on this social perspective is that we want to keep this IR 2022 Slack workspace open, so that we have this kind of record of all of our discussions, so we can have that as an important kind of legacy tools to refer back to build upon in future meetings, and also to encourage and continue future discussion about what we do for the next IR meetings. I think the other action item is that we really want to explore new scientific windows of opportunity with the ground-based mid-IR. And maybe I'm slightly biased in this, but I think that multi-messenger astronomy presents a really strong window of opportunity, but also opportunities with new facilities that are coming online soon, such as Mimizuku on Tau. And then I'll pass the floor to Abby.
Yeah, so when it comes to looking towards the future of infrared astronomy generally, we also had a diversity discussion session at the end of day 4. And I think a number of things were discussed there, which kind of feed into action items that we can all work on in the future as well. So we talked a bit about the current state of a diversity within our infrared groups and within the research groups that we're currently in. And it seems that we still have quite a way to go. And it's, you know, Astro inspires everyone, so everyone should be represented. And it's shown that just having greater diversity improves scientific discussions, with an example of a study here. It seems that there is still a kind of an imbalance between the kind of well, there's kind of the amount of diversity varies depending on the group you're in. Faustine Cantalou mentioned that instrumentation, for example, sees a kind of less representation from minority groups than others, for example. And I think in terms of improving this and making sure that across the board, we as a community have a good representation, is that we all need to be proactive in our improvement of diversity, whether that is kind of checking our own biases and making sure that's not affecting who we're hiring or who we collaborate with, and making sure that for the students and colleagues that we have from marginalized groups, that we're making sure that this is they're having you know, is a comfortable environment and they're not facing extra challenges because they are from a marginalized group as they work within our groups. And so I think we would looking to the future, checking our own biases and kind of making it a priority to have regular discussions about diversity, and also and to make sure that everyone is kind of supporting and standing up for our colleagues, which is very important going through, and making sure that we're not losing people from marginalized backgrounds as we go throughout our journey through infrared astronomy, and also throughout the career progression as well, and that we're not just losing all the students that we're hiring, and that they are getting towards these kind of higher level positions, which is kind of like the real change that we're looking for. So thank you. Oh, I think the quote has been like cut off, sorry, but and I just wanted to highlight this quote that Lynn gave, which is which says diversity is being invited to the party, but inclusion is being asked to dance, which is what that is meant to say. And I think that's just really indicative of what we need to do. We need to make sure that not only are we proactively encouraging diversity, but also keeping our environments safe enough for them so that people want to stay. And I think that's the big takeaway. So
thanks, Abby. Yeah, I'm glad you included that quote. All right, so thanks, Abby, for highlighting that very important action item for us in the infrared community. So this will be the last slide of this summary talk. I have some closing remarks, but I also wanted to kind of open the floor a bit for everyone who's online right now on Zoom or on Slack, and to just ask if there's any questions, comments, or feedback or thoughts on the future infrared meeting. We'll also leave the Slack workspace open so we can discuss in the Slack channel feedback for IR2020X. And I wanted to bring this back to my title or my intro slide, or this image from one of my intro slides, which is where we've come from in this kind of IR legacy of meetings. And it also raises the question of when should the next meeting be? The time between the 2018 meeting and the 2020 meeting was about 2 years. The time between the 2020 meeting and the 2022 meeting was about 1.5 years. And so we could do an IR 2023 or IR 2024. And of course, it should be motivated by, we should have a clearly defined motivation for what the purpose of the meeting would be. But I think this would be an interesting thing to consider, and also to ask for feedback on from IR 2022, and how we can apply that to make a successful future meeting. Yeah, so with that, I think we have several minutes or so for questions or discussions or thoughts. So I'll just open up the floor for any feedback from anyone. Yeah, Enrique, go ahead.
Hi. Yeah, so just following the trend of 2 years, so 2024, and also following the trends of different continents, I think that maybe US based IR 2024 will be good, and I will be happy to start the discussion or the conversation about organizing it here in California, if that is of interest for the people. The topic, of course, so we can discuss about what will be the specific topic to talk. But I think within 2 years, and knowing that the James Webb will be like in full operational and a lot of results outside, that will be a very exciting meeting to have with the new results of these ones, for example. Yeah, of the James Webb.
I don't know if I could just add on to that and advocate that it's a hybrid meeting so that there is like the opportunity for people all around the world to attend, because again, that came up in the diversity discussion that there are people from certain regions who can only join if there is an online option. So that sounds great.
Yeah, we need. Also... Go ahead.
Just to react on Abby's point, I think it's an excellent idea to have it hybrid or online if possible, but then we should also keep in mind that our Japanese friends and even some Australian friends who have been online have been staying up really late. I mean, for Ryan, I think it's 2 o'clock or something right now. So we should make sure that we're also more inclusive in this aspect and have perhaps more pre-recorded talks or somehow shorten the live session so that Japanese people don't have to stay up too long.
Yeah, so I think also we have enough time to really think about, if we do a hybrid, how to do very inclusive hybrid meetings, because in the past 2 years, I haven't had any good experience of hybrid meetings, but I mean, we have time to start thinking about it and how to do it as good and inclusive as possible for the next one.
Yeah, I agree with that point. I think I really miss in-person meetings. And I think if we can achieve some kind of balance between a hybrid in-person meeting without losing any of the, I guess, togetherness of a person who is trying to attend remotely, that would be excellent. I think, yeah, for now, it seems like that's still a little bit ways away, or we need to do some thinking to figure that out. But yeah, I think by the next IR 2024 or 2023 meeting, I think that could be something to look forward to.
So regarding regarding to one of the questions that you had in the previous slide from the previous Infrared 2020 about handbooks or for infrared observations and stuff. So maybe it's a general question, but what will be like a good impactful way to create some kind of like the primer of infrared astronomy, like handbook or paper that can, or white paper that can be published that way? So I don't know if it's gonna be like in terms of observing techniques or just a scientific cases that can be done in the infrared. Okay, Chris has a question there.
Yeah, he seems like he has a response to this.
Oh no, I've got a different point. Ryan, yeah, you can take that point. You can answer Enrique's question.
I mean, I think what makes it challenging for coming up with like a handbook for mid-infrared observations or different techniques is that a lot of them seem very specialized to the particular instrument mode or observation you're trying to do. And maybe that's what's difficult about it, is the overlap is there in terms of the wavelength, but the technical application, working through the pipelines, different pipelines that you're not familiar with, is yeah, that's a challenge, and especially making that accessible to other people, even other mid-infrared astronomers, I think is a challenge. Yeah, I think just meeting up more frequently and sharing like maybe your own cookbooks or user guides for your own particular instrument technique would be a valuable thing to do. So that could be something in the future meeting, is sharing how to operate a particular instrument mode and getting feedback on that, and coming up with ways to make that more accessible for the infrared community. Okay, Chris, do you have a point that you want to make, a question?
Yeah, just as we're getting towards the very end of the meeting, it would be remiss of me not to comment on a couple of things. So the SOC did a really good job, and I'm a member of the SOC, but I barely did anything as usual. But I did just want to call out Leo, Abigail, Hanai, but most especially Ryan. You did a huge amount of work pulling this all together. It's I don't know what, 3 a.m. or whatever time it is for you. So I just wanted to really give you a shout out, Ryan. This was a really well produced conference, and thank you for all that you did, and thank you for allowing me to be completely lazy.
Yeah, thanks for that comment, Chris. Yeah, I mean, it was really fun and interesting to try to organize this meeting. So yeah, I appreciate the opportunity to do this and to work with everyone and to yeah, to share this meeting with everyone. Okay, so yeah, I guess that kind of wraps up the time for the summary talk and discussion. So yeah, thank you everyone for all the feedback on this and the thoughts on this. So I want to finish up with just a couple slides or a couple closing remarks that I put together just to yeah, maybe just capture some sentiments of the meeting. So here's our group picture. Some of you may appear twice in it. But I think what was very clear to me throughout this meeting is we have a very radiant mid-infrared community and also mid-IR radiant. And so it was a real pleasure listening to all the talks, watching all the, looking at all the posters, pre-recorded talks, and all the material in this conference, and also interacting with everyone in it. It was a really, yeah, rewarding experience for me, and also just great working with everyone on this and trying to make this happen. I think we had an extremely engaging virtual meeting. I know things are very challenging during these times, and so I think just having this environment of this platform to get together and to chat and to talk about science and how we push in the future for new interesting observations with James Webb and all these other things. It's been really nice to be able to do this and connect with the rest of the mid-infrared community. So here's just some statistics of the meeting. So we had over 100 Zoom attendees at peak at some point. We have 200 active members on Slack. Our most active channels seem to be the Exoplanets, star formation, and high contrast imaging channels. And we have over 50 recorded talks and discussions uploaded on our IR2022 YouTube, which we were able to provide to you in less than 24 hours after they took place. And so we feel pretty good about that and making this available as rapidly as possible for people to catch up. We also took advantage of very interesting social platforms or tools such as Gather. And so here's a screenshot of us last night here in Japan when we had a discussion about the future of meetings. And so that was really interesting. I've never had that kind of interaction before on Gather, so that was really fun to do. I think we also took an interesting step into the future of virtual reality meetings. So if you haven't had a chance to do this, I don't know if we're leaving it up or not, but I think there still will be opportunities to explore this IR2020 space in AltSpace VR. And so here's a couple of the VR attendees here in this group photo. And I really want to acknowledge all the help and support that we got from the Future of Astronomy, Future of Meetings team. So they just were a huge part of making this VR experience happen. And yeah, basically we wouldn't have been able to do this without them and to try to demonstrate this for IR2022. So yeah, big thanks to them for pushing this. Yeah, so last thing I want to organize or to push for, sorry, this is an error here, I forgot to fix this. But we have this public talk series but next week from the 21st to the 25th. So I encourage everyone to check this out. And so you can view the website. Our website covers all the information of the public of these speakers who are attendees of the IR2022 meeting. I want to thank the SOC and VOC for all of the effort that they've put in for planning this meeting and making this a really awesome meeting. So we have an excellent and supportive team working across multiple time zones around the world that have put in a lot of work to prepare and facilitate this meeting. So I want to really thank them again for all the work that they've done. And I think, yeah, with that, I'll end on this last slide here, which is the first slide I shared during the meeting. So it also makes for a nice, I think, send off of this IR2022 meeting. So I want to thank everyone for making this an amazing meeting. I really enjoyed it, and I hope you did too. And I'm looking forward to an infrared bright future. All right, thanks everyone.